Hello friends, welcome to Learner's Planet. Friends, this is our sixth session for time, speed and distance. And I am sure you might have revised all the previous sessions and now you'll be gaining the confidence on the topic. In this session, we are going to take the cases of trains and boats. Okay, so let's begin to take the first question. In what time will a train 100 meters long cross an electric pole if its speed is 144 km per hour? Friends, we have discussed the concept of trains in our theory sessions. Further, I would just make a recap over here. Suppose this is a train over here and it has to cross this electric pole. The length of this train is 100 meters. That means the time taken by this train to cross this electric pole is the time taken by this train to run 100 meters with this speed. Okay, that means after crossing this pole, the situation must be like this. Suppose it is A and B, that means it is A and B. Okay, so the entire length of the train should be crossed by this pole. Okay, now here the speed is in kilometer per hour and the length of the train is in meters. So first let's convert this kilometer per hour to meter per second. So it is 5 by 18 we have to multiply to convert it to meter per second. So it is 8 5s are 40 meter per second. Now the train has to cross 100 meters with the speed of 40 meters per second. That means it will take 2.5 seconds. Okay. Friends, in the cases of trains, the length of the train is a significant factor. In other cases, like if a human being is crossing a pole or maybe a car or any other vehicle, if it is crossing a pole, then in those cases, their length or width is negligible. So we do not consider. But in these cases, sometimes the length of the trains are in 100, maybe in meters, maybe in sometimes it is 1000 meters, sometimes it is 600 meters. So the length is quite significant in this case. Okay. Now let's take the next problem. Quite similar problem to the previous one. That length of the train over here, it is 280 meters and it is crossing a stationary object. That is, in this case, it is a tree. Okay, and tree is a stationary object. Now the speed of the train is 63 km per hour. So let's convert it into meter per second. It's 35 by 2 meters per second. Okay, now how much time will it take to run 280 meters? That is 280 by 35 by 2, I'm sorry. So it will take 16 seconds to cross this tree. Okay. Now let's take this case. How long does a train 100 meters long running at the speed of 72 km per hour take to cross a bridge 132 meters in length? Friends, in this case, the length of this stationary object is also significant along with the length of the train. Okay, so suppose it is train, the length is 110 meters and this is bridge, the length of which is 132 meters. If this train is crossing this bridge, that means after crossing the situation must be like this. That means this point should come to this place. Okay, that means this point is for, moving 110 meters, then further it is moving 132 meters. That means this point is moving 110 plus 132 meters. Okay, and this is the ending point of the train. That means the train will have to cover this distance to cross this platform. Okay, so this is the distance and the speed of the train is 72 km per hour. Further, let's convert it to meter per second. So 72 into 5 by 18. So it is 20 meters per second. So this is the length and this is the speed. Okay, so it's must be 12.1 seconds. Okay, I hope you are clear. When a train is crossing a object which is also having significant length, maybe it is a platform, it's a tunnel, it's a bridge, or it is another train. Okay, so in that case we have to consider the length of the train as well as the length of that stationary object. Okay, now in this case a train running at a speed of 60 km per hour crosses a pole in 9 seconds. What is the length of the train? Now, or the length of the train will be same as when this train is crossing this pole with the speed of 60 km per hour in 9 seconds. Okay, so we have to calculate the distance in this case, and the distance will be nothing but the length of the train. So first of all, let's convert the 60 km per hour to meter per second. So it is 60 into 5 by 18, or we can say 6 3s are and 6 10. So it is 50 by 3 meters per second. And length of the train, that is distance covered by it with the speed of 60 km per hour in 9 seconds is, this is the speed and this is time. So it is 150 meters. It is nothing but the length of the train. Okay, so it's none of these over here. Now let's take this question. A train 240 meters long passed a pole in 24 seconds. How long will it take to pass a platform 650 meters long? First of all, we have to calculate the speed of the train. In this case, the speed of the train is its length by its time. Okay, so it's 240 by 24, that is 10 meters per second is the speed of the train. Now it has to cross a platform of 650 meter long. So we have already discussed in those cases the total length is, or the total distance to be covered up is the length of the stationary object as well as the length of the train. So it is 650 plus 240 is the total distance to be covered up to cross this platform with the speed of 10 meters per second. It will take 89 seconds. Okay, I'm sure you are clear. Now let's try this question. The length of the bridge which a train 130 meters long and traveling at 45 km per hour can cross in 30 seconds is. A very simple question. In this case, the length of bridge is missing, so that we have to find out. First of all, let's convert the speed into meter per second. So it is 45 into 5 by 18. So it is 25 by 2 meters per second, and we can say 12.5 meters per second. Okay, now the total length which we have to consider is the length of the train as well as the length of the bridge. That means the total length is x plus 130. We can say the length of bridge is x meters. Okay, now this is the total length which has to be covered up. This is the speed, that is 12.5 meter per second. So distance by speed is time. Okay, so x plus 130 is 12.5 into 30. So it's 375. So x is equal to 375 minus 130. That is 245 meters. As simple as that. Okay. I hope you are clear. Let's take the next problem. Now friends, try this question on your own. Just pause the session and then match your solution and answer with mine. Okay, and let's see how much you are getting the concept of trains. A train 800 meters long is running at a speed of 78 kilometers per hour. If it crosses a tunnel in 1 minute, then the length of the tunnel in meters is. Further, quite similar case as the previous one was. Now, in this case also we have to consider the length of the train as well as the tunnel. Okay, first of all, let's convert this kilometer per hour to meter per second. So it is 78 into 5 by 18. Okay, so it's It is 65 by 3 meters per second. Now, the total length which has to be covered up is the length of the train plus length of the tunnel, which is x meters, let's assume. And the time it is taking is 60 seconds. That is 1 minute. In this case, it is 60 seconds. So this is the speed and this is the speed. Okay. Now just calculate and get the value of x. It's 2400 plus 3x is equal to 60 into 65. Okay, so 3x is equal to 1500, x is equal to 500. That means the length of the tunnel is 500 meters. Okay, I'm sure your answer and solution is matching with mine. Friends, if you could develop or if you could exercise mental exercise, you'll be able to solve this sort of problems even without the use of paper and pen. Okay, let's take the next problem. Further, the similar question, try it on your own and match your answer with mine. Just pause the session. The length of the train and that of a platform are equal if with a speed of 90 km per hour, the train crosses the platform in 1 minute, then the length of the train is. Friends, let's try to do this problem without the use of paper and pen. Here the speed of the train is 90 km per hour. So if we wish to convert it to meter per second, we need to multiply it by 5 by 18. So it will be 90 into 5 by 18. Just try to visualize. It will be 18 fives are and 5 into 5. That is 25 meters per second is the speed of the train. Okay. Just try to visualize. Okay. Now speed of the train is 25 meters per second and the length of the train and platform is equal. That means the total length which has to be covered up is 2x. Okay, so 2x is the total length which is being covered by this train in 1 minute, that is 60 seconds. So 2x by 60 is 25, isn't it? Length of the train plus platform, that is the distance covered up, by time, that is 60 seconds, is the speed of the train. Okay, so 2x by 60 is 25. That means x by 30 is 25. That means x is equal to 30 into 25, that is 750 meters, isn't it? Very simple. I don't think I need to solve the problem on paper and pen for you, and I hope your answer is matching with mine. Let's take the next problem. Friends, further we are taking the similar problem, and just pause the session, try the problem on your own. As far as possible, do not use your paper and pen, or maybe if it is required, just make a minimal use of it. Okay, so while solving these problems, I think your mental exercise will be done and you'll be able to visualize the calculations in your mind. Okay, and in examination it will be really very useful and you'll be able to save a lot of time. Okay, now let's take this problem. A train of length 150 meters takes 40.5 seconds to cross a tunnel of length 300 meters. Okay, now what is the speed of the train in kilometer per hour? First of all, the total length to be covered up or the total distance to be covered up is the length of the train plus length of the tunnel, that is 300 plus 150, that is 450 meters. Okay, now this 450 meters the train is taking 40.5 seconds to cover. That means the speed of the train is 450 meters by 40.5 seconds. So it's this. So 405 and 4500. So 4500 and 45 nines. Okay, so it's 100 by 9 meters per second. Now we have to convert it into kilometer per hour. So we'll be multiplying it by 18 by 5. Okay, so 9 twos and 5, 20. So it is 40 kilometer per hour. Okay. Now further we'll try to do this problem mentally. A train crosses a platform 100 meter long in 60 seconds. at a speed of 45 km per hour. The time taken by the train to cross an electric pole is, first of all, in this case, the data, that is the length of the train, is missing. First of all, we have to calculate that. Okay. Now the total length which has to be covered up is the length of the train plus length of the platform. Suppose it is x plus 100. Okay. So the total length is x plus 100, and it is covering the length is in 60 seconds. So this is the speed of train, and actually it is 45 into 5 by 18, that is in meters per second. Okay. So it is x plus 100 is 750. So x is 650 meters. That is the length of the train. Okay. Now this is the length of the train. This is the speed of the train. So we can calculate the time taken by train to cross an electric pole. So it is length of the train divided by its speed. Okay. It's 52 seconds. Okay, as simple as that. If you are conceptually clear, you can do this problem in seconds only. Okay, let's take the next problem. Now further, an interesting question. In this case, let's see, a train passes a station platform in 36 seconds and a man standing on the platform in 20 seconds. If the speed of the train is 54 km per hour, what is the length of the platform? Friends, let's try to do this problem mentally. Let's not make any use of paper and pen. This train is crossing a man, that is a stationary body, in 20 seconds, and the speed of the train is 54 km per hour. So first of all, let's convert it into meter per second. So it is 54 into 5 by 18. So 18 threes are 54. That means 3 into 5, 15 meters per second is the speed of the train. Okay, 15 meters per second. Now it is crossing this person in 20 seconds. Okay, now in that case, what will be the length of the train? That is in 15 meters per second. It is running for 20 seconds. So the length of the train is 15 into 20, that is 300 meters. Okay, now 300 meters is the length of the train, and now we have to calculate the length of the platform. So the total length which has to be covered up is the length of the train plus length of the platform. Okay, and the length of the train is 300, and let the length of the platform is x. So 300 plus x by 36 is equal to 15. Okay, you're getting my point? 300, that is the length of the train, plus length of the platform by 15, that is 54 km per hour. If it is converted to meter per second, it is 15, and it is 36. Now we can calculate the length of the platform, isn't it? So it is 300 plus x is it's 240 meters. Okay, so with the minimal use of paperwork, we have solved this problem, and I hope you might have also done the same way. Okay, let's take the next problem. The length of the platform in this case is 240 meters. Okay. Now try this problem. A train takes 18 seconds to pass completely through a station 162 meters long and 15 seconds through another station 120 meter long. The length of the train is. Friends, very simple question. We have to calculate the speed of the train. In both the cases, the speed of the train is same, as we can assume that. Okay. Now the total length which has to be covered up is the length of the train plus length of the station. That is, we assume the length of the train to be x. So the total length in the first case is x plus 162, and the train is covering this length in 18 seconds. This is the speed of the train. Similarly, in other case, the total length is x plus 120, and the time which is being taken is 15 seconds. So this is also the speed of the train and this is also the speed of the train. So we are just going to equate them. So x is equal to 810 minus 720, that is 90 meters. Okay, very simple question. Now friends, let's try this question. How many seconds will a 500-meter long train take to cross a man walking with a speed of 3 km per hour in the direction of moving train if the speed of the train is 63 km per hour? Now suppose this is a train and its length is 500 meters. This person is somewhere here and the speed of this person is 3 km per hour, and this person is also moving in this direction and the train is also moving in this direction. That means we have to find out the relative speed of the train, that is the extra speed of the train from that particular person, or we can say the gaining speed. Okay, so it is what? It is 63 minus 3, that is 60 km per hour. So that means if this train is crossing this person, its gaining speed will be considered. Okay, so it is 60 km per hour. Let's convert it into meter per second. So it is 60 into 5 by 18. So it's 50 by 3 meters per second. Now the length of the train is 500 meters and this is the speed. So we can calculate the time. So it's 500 by 50 by 3. So it is 30 seconds. Okay, I hope you are clear. Friends, there are two types of cases when a train is crossing a moving body. In this case, the person is going in the same direction as the train, and maybe the cases are there when the person or the moving body is going in opposite direction with respect to train. Okay, so in both the cases we have to consider the speed of that moving body also, because if both the bodies like the train and the person are going in the same direction, that in that case the train will take more time to cross that moving body. Okay, and in other case, if the train is going with the in the opposite direction of the person, then in that case the train will take lesser time to cross that moving body. Okay, so we have to be very clear with both the concepts, and that other moving body can be sometimes moving trains also, so we'll be taking the problems of even moving trains also. I hope you are clear. If both the bodies like train and the person, if they are moving in the same direction, then the relative speed will be difference of their speeds, and if they are moving in opposite direction, then their speeds or the relative speeds will be addition of their speed. Okay, now let's take the other question. Further similar problem. A jogger running at 9 km per hour alongside a railway track is 240 meters ahead of the engine of a 120 meters long train running at 45 km per hour in the same direction. In how much time will the train pass the jogger? Just draw the diagram of it. Now let's assume this is the train, that is 120 meters of length, and this person is as of now he is here, that is this length is 240 meters. Okay, and this person is moving with the speed of 9 km per hour in this direction, and the train is also moving in this direction. So its speed is 9 km per hour and its speed is 45 km per hour, and both of them are moving in the same direction. That means the relative speed is 45 minus 9. Okay, so that is 36 km per hour, or we can convert it into meter per second. So it's 10 meters per second. Now important part over here is this train has to first reach to this person, then it has to cross this person. That means the total length which has to be covered up is 120 plus 240 with this speed. So the total length is 120 plus 240, that is 360 with this speed. That means it will take 36 seconds to cross this person. Okay. Friends, there are two types of cases. One is, in this case, as in this case, this person is 240 meters ahead of engine. Okay, so engine is here. Okay, now this train is crossing this person. That means the last part, that is the ending part of this train, must cross this person. That means this ending part has to cover the distance of 120 plus 240, that is 360 meters. Okay, if the scene is like this, I just draw the diagram. If the scene is like this, okay, this is train and the person is standing over here, and this length is 240 meters. That means this length is I'm sorry, it is 120 meters, and this total length is 240, and this length is 120 meters. That means the last part of the train, that means the last ending part of the train has to cover this 120 plus this 120, that is 240 meters only to cross this person. Okay, so in that case, 240 meters with the speed of 10 meters per second, it will take 24 seconds. Okay, so we have to be clear about both the cases. We have initially the situation of train is what is the main part. Okay, if it is situation is like this, then this calculation will be there, and if the situation is like that, the engine is 240 meters from this person, then the previous case has to be considered. Okay, now let's see this problem. A train 110 meters long is running with a speed of 60 km per hour. In what time will it pass a man who is running at 6 km per hour in the direction opposite to that which the train is going? Okay, now in this case, the train is going in this direction and the person is coming from this direction. That means the relative speed will be the difference, the addition of their speeds, that is 60 plus 6, 66 km per hour. Now let's convert it into meter per second. So it is 66 into 5 by 18 meters per second. Now we have to find out the time. The length which has to be covered up is 110 meters and the speed is 66 into 5 by 18. Okay. So it is 6 seconds. Okay. Now here comes an interesting case. Two trains 200 meters and 150 meters are running on parallel rails at the rate of 40 and 45 km per hour respectively. In how much time will they cross each other if they are running in the same direction? Friends, very interesting question. Both the bodies over here are having considerable length and they are moving in the same direction with the respective speeds. Now we have to find out the time when they cross each other. Okay, now let's draw the diagram. Just see here, this is the train whose length is 200 meters and it is moving at the speed of 40 km per hour. And length of this train is 150 meters and it is moving at the speed of 45 km per hour. So this train will cross this train. To cross this train, the last part of this train must be over here, and after crossing the scene must be like this. Okay, so this is suppose A and B, it should be A and B. That means the total length which has to be covered up by this point is the length of this train plus length of this train, that is 150 plus 200, that is 350 meters. Okay, Now what is the relative speed? This train is also moving and this train is also moving. But in this case, both of them are moving in the same direction. That means the relative speed will be considered, or the gaining speed will be considered. So the gaining speed is 5 kilometer per hour. That means this train is running 5 kilometer extra than this train. Okay. So to gain this distance, 350 meters, to gain this distance, it will take what time, that we have to calculate. So first of all, just convert this speed into meter per second. So the relative speed is 5 kilometer per hour. So 5 into 5 by 18 is the speed in meters per second. I just write it over here. Okay, so this will be the time. So it's 14 into 18. Okay. So 180 plus 72, that is 252 seconds. Friends, I hope you are clear with the method. Now let's see this case. Two trains 140 meters and 160 meters long run at a speed of 60 km per hour and 40 km per hour respectively. Maybe this is of 140 meters and this is of 160 meters. And the speed is 60 km per hour and speed is 40 km per hour. And they are coming from opposite direction. Okay, and we have to find the time when they cross each other. Okay, now friends, to crossing means this last point should cross this last point. That means after crossing, the scene must be like this. That means this last point has to cover a distance of 140 plus 160, that is 300 meters. And since both the trains are coming from opposite direction, their relative speed will be addition of their speed, that is 60 plus 40, 100 kilometer per hour. So it's 100 into 5 by 18 meters per second. Okay, so it's 54 by 5, or we can say 10.8 seconds. Okay, I hope you are clear. Friends, I hope you might have enjoyed the session and you might be doing the problems with me. I'm sure that you'll be gaining confidence in time, speed, and distance, these simple problems. We'll be taking more such problems and concepts in our next session. Till then, do revise this session and the previous sessions of time, speed, and distance. Okay, bye-bye.